In problem number 20, it says you have angle C of 55 degrees, side A 17, and side C is 15. So here's the given information. And what you're looking to do here is you're looking to figure out what are the remaining pieces of information for this triangle. Okay, well, there happen to be two triangles that can be formed here. We can tell that we have the SSA pattern. So SSA pattern means you're going to use the law of sines. And then you have to choose either one or two triangles. The fact that the side opposite the given angle, 15, is smaller than 17, the other given side, means we're dealing with two. Okay, so the first triangle that we're going to look at is this triangle that's just given in black here. Okay, so we can set up the law of sines here. We have our set ratio. The set ratio are these two opposite pieces that we know. Okay, and so we want to find A. So if we set it up, the sine of A over the side opposite it is equal to the sine of the known angle measure, 55 degrees, over the side opposite it. And we're going to solve for our unknown. Well, again, anytime we're solving for angles like this, our calculators can't actually calculate that, so we have to use a substitution. We'll let x equal the whole sine ratio for A. And so if we substitute that in and we solve, F2 algebra tab, choose x divided by 17, set that equal to the sine of 55, I'll put a decimal here, divided by 15, and we're solving for x. Now, the expectation is this is a number that's going to fall between -1 and 1, okay, and it does. So we get our value for x of 0.928. That means that's what our sine ratio for angle A has to be. And if we want to solve for A, we're going to take the inverse sine of that ratio, and that's going to give us the corresponding angle measure. So if we take the inverse sine of x, use the with key, and then just identify what x is going to equal. Again, it just saves us the time of having to go in and delete the x equals on this. We get our angle to be 68.2 approximately. And once we have that angle, we can go in and find B by taking the sum of the angles of a triangle is 180, subtract the known angle of 55 and the angle we just found, 68.2. And when we do that, we get our other value, 56.8 approximately. Okay, the last step is once we have this piece, we can find the side opposite it, B. So we can set up a ratio again using law of sines. B over the sine of 56.8 is equal to, we're going to use the same set ratio here, but since we started with the side, we'll start with 15 over the sine of 55 degrees. Do the same thing, we're going to solve. Okay, this time, again, x is just going to be used to make it easier to type in, but it's designated for a side, so it's going to give me the answer. I don't have to use any kind of substitution. So I'll hit F2, the algebra tab, choose solve, type my equation, x divided by the sine of the angle that we just found. Set that equal to the ratio 15 divided by the sine of 55. Comma x identifies that that's the variable we're solving for. When I hit enter, I get my solution. B is 15.3 if you're rounding it to the nearest tenth. Okay, now let's test it or check this and see, is this consistent with what we would expect? Is the smallest side opposite the smallest angle? Yeah. Is the longest side opposite the largest angle? Yeah. So it's at least consistent with what we were expecting. Okay, now let's take a look at the second possibility. Now we saw that there were two possible triangles. If we take this side of 15 and we swing it along a circular path, we can find where the other triangle is going to be. So if I redraw this, okay, so here's C, here's B2, and here's A2. We still have the same lengths of 17 and 15. We still have the same given angle, 55 degrees. Okay, the difference is we now need to find this new angle 2. Well, the new angle 2 can be found pretty easily because this triangle that's formed here is an isosceles triangle, which means base angles are equal. So this measure is 68.2, which means the angle that we're looking for right here is going to be 180 minus the original angle A. So if I took 180 and I subtracted my A value, which was 68.2, so go up and select that piece, I get my angle to be 111.8. That's my new angle. And then I can use that angle plus the 55 subtracted off from the total sum of the angles, 180. So 180 minus 55 minus the angle that we just found for A2. That's going to give us B2, 13.2 approximately. And then finally we can solve this side B2, setting up the same ratios we did out here. B2 over the sine of the angle opposite it, which is now 13.2, is equal to the same set ratio. And we're still going to solve for the same thing. If I'm solving for B2, I'm just going to make it an X to make it easier. And so my calculation winds up being the exact same as this original calculation, or nearly the exact same. When I calculate it, F2 algebra tab, X divided by the sine of the angle 13.2, set that equal to the known ratio 15 divided by the sine of 55, comma X tells the calculator that I'm solving for the measure 4.2 approximately would be the length of that last side.